Hi, welcome back to more coverage from CES 2014. I'm here today with Ian Drew, who's the Chief Marketing Officer for ARM. Ian, interesting stat the other day. You guys have shipped more than 50 billion processors. Now most people know you from smartphones and tablets, but you guys ship for a whole lot more products. Can you talk about some of those and some of the marketing challenges that go with them?
At CES, you come here and you see wonderful new things. When we came here 4 or 5 years ago, it was the start of this tablet revolution. And you started seeing phones with browsers coming a couple of years before then. When you come this year, you see health, you see sport, you see embedded technologies. And this is going to lead to billions and billions more of ARM-based processors. We've seen this revolution happen, and people call it the Internet of Things, but it's really this connecting devices that you and I see as commonplace really becoming connected to the internet and using them in brand new ways that we wouldn't have thought about a few years ago.
When you have so many partners across so many industries and being the marketing boss, how do you keep a whole bunch of partners in one industry happy?
Well, you have to look at this and go, this ARM ecosystem allows diversity. It's not about standardizing on one chip or one device. There is so much diversity that goes on in both the SoC design, in how the software is put together, in the power and dynamic range. We have multiple different product lines. So we have Cortex-M, which is deeply embedded, Cortex-R, which is real-time, and that goes into things like braking systems in cars. And then Cortex-A, which we're famous for, that goes into apps processors in tablets and phones and other big devices. So we've diversified our range over the last 5 years, and we're really starting to target different processes in different areas, but without going, you must put this next to it, or you must use this memory, or you must use this graphics controller. There's so many different ways you can diversify, and I think you've seen that in the phone and the rest of the IoT industry.
So following on from that, if they can diversify, how much control do they have over the shipping technology?
They have ultimate control. They have to pass a test which says it's ARM compliant, and because we want to keep the same instruction set, we want to keep the same software, we want to make sure that software runs across the whole range. But what we don't do is go, outside of that, you can put anything you like next to it. So for us, this diversity is critical to our business model. And we will never come to the stage of telling people what to go design and what to go build. That's an old world style of things. A new world is how to go and embrace this diversity and create a plethora of products that go through the whole roadmap of what's possible.
Okay. From an engineering standpoint, are you worried at all that rival companies have a process lead, or is process a matter that's not that important to you guys?
Process is always important to us. And it's probably an Intel question, because Intel goes
Sure.
out and says, you know, we've got a lead in process technology. The lead in process technology is really for their very high-end parts. And if you look at volume, which is where all of our partners care about, having shipped 50 billion parts and billions a year, we care about volume production, not just that very niche leading edge. And we think we're effectively the same as Intel, if not better, when it comes to volume production. And we work with our partners both in the semiconductor space and the fab space to make sure that time to volume is really where it's at, because that's where the money's made, that's where the profitability is, that's where the volume is, and that's where the leading edge phones and tablets and everyone else is.
Okay, speaking about leading edge phones and tablets, if I look down your roadmap and rivals, you can see 2-3x the power or performance in 2 years' time. What kind of applications can you foresee that would require that?
Well, when you say 2-3x the power, I think you mean 2-3x the performance. Because
power and performance.
The power is going to be the same, if not better. Things like Big Little enable much better performance with the same or lower power. And so you're seeing huge dynamic range increase over the next few years. You're seeing 64-bit come in, you're seeing higher end quad cores and people doing octa-cores, a range of things coming out. And so you'll see real-time video processing for 4K on tablets and phones in the next few years. People walking around and editing their videos And instead of using a PC, you'll use a phone or a tablet now. That's where the high end's going. And then the volume is going to be huge amounts of 32-bit and then moving into 64-bit at the price points that people really want to go and buy at as well.
Okay, so the mid-range now, would a mid-range phone now be the entry-level phone of 18 months' time? Can you quantify how these things change?
You look at this, I look at it in Moore's law cycles.
Okay.
I'm an old school techie guy when it comes to that. Performance doubles every 18 months. You can use that to get better performance, or you can use it to save silicon area. And so it is about an 18 months, 1 year to 18 months, as things roll down from the high end to mid-range to the low end.
And defining high-end, mid-range and low-end is sometimes done by us anyway, the press, with benchmarks. Now, benchmarks on a PC, where we're from, relatively straightforward. With mobile, one company can claim all sorts of things. And I know it's a topic that's close to your heart. So what do you think about the state of benchmarking right now for mobile devices?
The problem with benchmarking is this diversity. The problem with the PC industry was everybody did the same thing. So it was very easy to go and benchmark a laptop because it's had the same operating system, the same processor, and there was very little change that you could put in there to improve the benchmark. So effectively, you benchmark the same thing, one after each other, and you got slightly different results depending on your memory performance or how your hard drive was. Move on to this new world and this huge change where anybody can use different graphics, anybody can use different memory, different I/O. You can put 16 FinFET, you can do 20 nanometer, you can do different geometries, you can configure it in different ways, you can use different bus architectures, totally different world. So benchmarking becomes a lot harder. Mm-hmm. What you now have to do is look at real world applications and start not just from how many megahertz does it do, but what sort of applications people are using, what sort of graphics are they doing, how are they interacting with this, and start benchmarking in that way. And we think that's the new way of benchmarking, really looking at real world applications. And we're starting to see some of these new benchmarking starting to come out, people looking at how they do that. And I think that will give end users real results of what they want to see, not just how much memory it's got or the different configurations are inside.
With a whole bunch of new applications, they tend to be more GPU intensive. The GPU is just quicker at doing parallel tasks. Does that mean the CPU becomes less relevant in future ARM designs?
I think it actually becomes more relevant. I think if you look at the way the GPU and the CPU interact, you will see GPU, CPU, GPU compute moving forward. I think you can have specialized tasks and you can have generic tasks. I think you'll see a lot more intelligence about which processing element is best for which task and how you split it up. I think you'll see that balanced architecture continuing going forward over the next few years.
And you think HSA will help you guys?
We think HSA will help the industry, not just us. HSA is a big industry initiative, and it's about this balanced computing, how you do which task is right for which core, not just we're going to manually go, this runs on the GPU. GPU is a great engine, we love them, but you have to run specialized tasks on there, otherwise it becomes very power inefficient. It comes out very slowly. You need to have efficient parallel tasks for the GPU, you need to have specialized tasks, you need to have the general task for the CPU.
Yeah, speaking about general tasks, that appears to be something the CPU is good at for servers. And you guys have made quite decent strides in recent years for servers. Can you talk a bit more about what ARM is doing in that space?
When I wrote the original white paper 6 years ago on servers, and I was looking it up the other day, and if you look at where we are, we're now going from this 32-bit world to this 64-bit world. We have some of the software in place. You've seen the Linux companies come and support us. You've seen some of the middleware companies coming to support us. We actually have real deployments in the field running real applications last year. You'll see significantly more this year, and you'll see growth over the next 3, 4, 5 years as this 64-bit architecture comes out. We think that low power, the new architectures that we bring in place, the bringing together of some of these network elements, and also our business model, which allows customization and diversification, will bring a whole new paradigm to this server space. We think that that is the way that's going to revolutionize this space over the next 3 to 5 years.
Okay. Changing gears, A big topic in CES is wearable tech, and you guys happen to be at the heart of that. Is that a fad, or is it something that's here to stay?
Had you have asked me 2 years ago, is it a fad? I'd have probably said, I'm not sure. Now it's here to stay. You've seen everybody having watches. I've seen more watches over the last 18 months than I ever thought I would see. You are seeing heart rate monitors, you are seeing step monitors, you're seeing earrings. I think every body part has something attached to it now. That's going to stay. The real issue is not going to be, will the low power be able to cope with this? Because I think you're getting days, weeks, months of battery life out of some of these monitors. It's how you bring the systems together, what's the software, what's the model for data, what's the security model around some of this? Because clearly in the health market, you need to make sure a lot of this is protected as well. So we're looking at ways in which, over the next few years, it becomes a proper system rather than just hardware that connects up to an app.
Can you also talk about what you believe to be the next big thing? Health is here now. What else can ARM facilitate in the next few years?
I think you'll find that there's going to be three things that come out over the next 3 to 5 years that really drive how this market will go. I start at the high end. We've talked about servers, but I think all this networking and server coming together with the amount of data coming out, we'll see huge growth, revolutionizing not just data centers, but how this whole industry of data movement happens. Because you can't keep on building power stations all the time to feed data centers and switches and routers. We need to fix that one. The phones and the tablets, you're seeing revolutionary price points coming out now. Sub $100. I was in Taiwan before Christmas and I bought sub $50 tablets. You're seeing that going into emerging markets. You're seeing phones going into emerging markets. And these markets are being fed for the first time with compute devices that people can use. How do you revolutionize education? You put power into people's hands, but you also then need to feed the software into that space. And then the third one is called the Internet of Things. And I think the Internet of Things, IoT at the moment, I think we're going to not call it the Internet of Things in 3 years' time because everything will be connected. The revolution there is how you get all of that data into the big data as efficiently as possible. You can't have a huge amount of data going across a very low power sensor because it drains the battery. How do you revolutionize that to have sensors everywhere that makes this world possible, but take that data and feed it through a network of both clients and servers that really change the way forward? I think the next 5 years is probably more exciting than the last 5 years in this industry.
So with those scenarios, are you actively changing the way you design chips to accommodate the needs of those functions?
I think we've already changed. If you look at some of the roadmaps that are going to be announced over the next few years, we've been thinking about this for the last 3 to 5 years. This is not something that we take as a revolution. We've been evolutionary changing our roadmap over the last 5 years to make all of this into account.
Okay. As a final question, what is your favorite ARM-powered device?
My favorite ARM-powered device, and my favorite guy that I work for, Warren East, used to use a fountain pen. I saw a fountain pen the other day with a tracking arm micro sensor on it that you could use both as a fountain pen but would also feed into your tablet. So as an honour to Warren, I looked at that and thought that's my favourite device this year.
So there you go, that's interesting insights from ARM's marketing boss. Do check back for more coverage from CES 2014.